Hello class, today we're on 5.9, extraneous solutions and proper rational functions. So the main point of today's lessons will be solving for x and finding what we call extraneous solutions. And then I just had another little thing I wanted to add with the proper rational functions, because you will have a question in your test about proper rational functions. So a proper rational function is a function, a proper rational function is a rational function where the degree of the bottom polynomial is greater than the degree of the top polynomial. So all three of these are examples of a proper rational function. Notice the degree of the bottom here is 2, the degree of top here is 1, the degree down here on bottom is 1, degree up here is 0, degree down here is 3, and the degree up there is 2. So, that's just what a proper rational function is, but let's go on to the main part of today's lesson, and that's on solving for x and finding extraneous solutions. So, an extraneous solution is a solution that doesn't satisfy the original equation. So, what happens oftentimes in rational functions is we will solve for a function, or we'll solve for x, but we'll get an answer that doesn't quite make sense, and we have to check for those after we're done solving for x. So here are the steps to solve for x. First step, we need to multiply both sides by the denominator to get rid of the fraction. So we want to first just get rid of the fraction. After that, we will go ahead and solve for x. And then after that, we need to check for any extraneous solutions by plugging it back in and seeing if or seeing what we get. So let's go straight to some examples here. All right. So let's take a look at this top left one here. This x squared minus 3x minus 10 over x plus 2. Well, so our first step says to get rid of the fraction. So what we want to do is we want to multiply both sides by x plus 2, right? It's being divided, so let's multiply. So we're going to multiply this left side by x plus 2 and multiply the right side by x plus 2. Now what that's going to do on the left, it's going to cancel this out. So what we're left with on the left is x squared minus 3x minus 10 equals, and then, well, what's 0 times anything? It's just going to be 0. So now what we can do is we can solve for x. And remember, solve for x when we have a trinomial like this, that's a quadratic. We can either use the quadratic formula, or we can factor if it's factorable. But all of these will be factorable, so let's use the factoring method. So I need to find two numbers that add to negative 3 but multiply to negative 10. That's going to be negative 5 and positive 2. Now, what we can do is we can set each factor equal to 0 and solve for each x. So we have x minus 5 equals 0 and x plus 2 equals 0. So we just add 5 to both sides here. So one solution is x equals 5, and the other solution, subtract 2, x equals negative 2. So we have our two solutions. But let's plug it back. Let's plug them back in and see what we get here. So make sure that after we plug it in, we get 0. So let's start with 5. Let's see here. By plugging in, we're going to get 5 squared. That's up here. Minus 3 times 5. Minus 10 over 5 plus 2. Well, simplifying that, let's see, 5 squared is 25, so 25. Negative 3 times 5 is negative 15, minus 10. Oh, this equals 0, right? Over 5 plus 2 is 7, equals 0. And let's see here. 25 minus 15 minus 10 is 0, so we do have 0 over 7. That is awesome. So good. So 0 is equal to 0. So 5 is a solution. Now let's check negative 2. Now we'll have negative 2 squared minus 3 times negative 2 minus 10 all over negative 2 plus 2 equals 0. Now, immediately I see what the problem is here. Now, this top here, negative 2 squared is going to be 4 plus 6. All right, this is going to be, so it's going to be 4. Negative 3 times negative 2 is positive 6 minus 10 over, and then negative 2 plus 2 is 0. So notice what's going on here. We have a 0 on the bottom. We cannot have that. So, although the top is going to go to 0 here too, right? 4 plus 6 minus 10 is 0. We have a 0 on the bottom, which can't happen. So this is our extraneous solution, negative 2. So our only answer here is x equals 5. Now, once you kind of get the picture here, right, you can kind of see, you can kind of do a shortcut and see, oh, well, what number do I plug in for the bottom? That's going to give me a 0 on the bottom. That's going to be our extraneous solution. So let's keep that in mind as we go through these next few examples. So here, again, first step, we want to multiply both sides by the denominator to get rid of that fraction. That will cancel. So what we have here is x squared plus 9x plus 18 equals 0. All right, 0 times whatever is always 0. And then let's factor. Two numbers that add to 9 but multiply to 16. That's going to be positive 3 and positive 6. And then solve. So this is going to change signs, right? This is going to be x equals negative 3. Or, well, I won't skip that just so we can see it. X plus 3 equals 0. We set each factor equal to 0 and solve for x. X plus 6 equals 0. So if we subtract 3 here from both sides, we can get x equals negative 3. And if we subtract 6 here, we're going to get x equals negative 6. Now, my question to you is, which one of these are the extraneous, or which one of these is the extraneous solution? And that's going to be the negative 6. Because right away I can see that if we plug in negative 6 in for x here, on the bottom we're going to have 0, which we cannot have, which this is our extraneous solution. So our only answer here is negative 3. Alright, let's do a couple more here. Let's see, so we're going to multiply both sides by x minus 3, the denominator. This is going to cancel for us, so we have x squared minus 7x plus 12 equals 0, right? 0 times this is just 0. And then we're going to factor, so two numbers that add to negative 7 but multiply to 12. And that's going to be negative 4 and negative 3. Right? Negative 4 minus 3 is negative 7. Negative 4 times negative 3 is positive 12. So, set each factor equal to 0 and solve for x. As you can see, this is going to become positive 4, and this is going to become positive 3, if you're to do the math. But which one of these is extraneous? Well, the 3 is extraneous, because I see if I plug it in, we get 0 on the bottom, so we can't have this. So this is the extraneous solution. And this is our answer, x equals 4. Alright, one more. So, again, multiply both sides by the denominator. This will cancel, so we have x squared minus x minus 20 is equal to 0. Now, two numbers that add to negative 1 but multiply to negative 20, that's going to be negative 5 and positive 4. So x minus 5, x plus 4, and that equals 0. And then set each factor equal to x, or set each factor equal to 0 and solve for x, which is going to give us x equals 5 and x equals negative 4. And then checking for the extraneous solutions, we see if we plug in negative 4 in for x, we get 0 on the bottom. So this is extraneous. and 5 is our answer here. So when doing these, we'll always have a real answer, and then we'll have an extraneous answer. Also, on the worksheet, you have questions that ask about not only which is like a proper rational function, but you'll have questions asking about horizontal asymptotes. So it'll say like which one of the following functions has a horizontal asymptote at x equals or at y equals 3 or something. Well, my advice to you is just use Desmos and plug all of those value or all of those functions in and see which ones have horizontal asymptotes at that value. So that's all I have for you today. I hope this video helped, and let me know if you have questions. Have a good day.